Hello, and thank you for joining me. I'm Evelyn Zayas, an assistant professor in the School of Technology at Rasmussen University. I've worked in industry as a software engineer for many years and have been teaching computer programming and computer science topics for years. Do you want to learn how to become a better programmer, or a better graphic designer, or a better web developer? Sound too good to be true? Grab your favorite beverage, take a listen for about 15 minutes, and then you be the judge.
Let me tell you about my friend Angela. She is now a freelance software developer after spending about 5 years working as a full-stack developer in the automotive parts industry. She wants to specialize in web app development and is looking to find her niche. She enjoys the creativity of graphic design, which is about using visual and textual content to convey information. While chatting about her ideas with her husband, who is colorblind, he mentioned that it is sometimes hard to read screens and web pages because of the colors and fonts used. Angela decided to learn more about color blindness to ensure that the color schemes that she used in her web apps and GUI designs are easily readable and accessible. She learns that color perception in the human eye works through cells called cones, which are sensitive to different colors of light, red, green, and blue. When light hits these cones, they send signals to the brain, which combines them to let us see a wide range of colors. Just like mixing different paints can make new colors, our eyes mix signals from the cones to create the full spectrum of cones we see. Color blindness occurs when the cones in the eye don't work properly. This can happen if one or more types of cones is missing, not functioning correctly, or detect a different color than usual. She was surprised to learn that more than 99% of color blindness is from a red-green color vision deficiency. About 8% of all men and 0.5% of all women have red-green color blindness. This condition is usually inherited and passed down through families. But not only are the colors red and green hard to distinguish from each other, the whole color spectrum is affected by this color vision deficiency. Actually, my husband is also red-green colorblind, and he sees the color gray as pink. There is also blue-yellow color blindness, but it is quite rare. People with this condition confuse blue with green and yellow with violet. Angela came across the Coblis Color Blindness Simulator website, which was pretty cool because it shows what people with different types of color blindness may see. By default, it displays an image of crayons of different colors, but you can also upload your own image. From her researching into color blindness and how to make UI designs more accessible, Angela came away with a few easy-to-implement design principles that would make a big difference. For example, she learned that she should avoid certain color combinations that are known to be difficult for some people to distinguish. For example, combining red and green together in an image or using a red and black font together are just two examples of color combinations that are problematic for many people. Another accessibility issue is using color as the only way to convey error information during actions such as form submission. Including another visual indicator such as a noticeable icon that highlights the location of the error would help here, and another item on the checklist for making more accessible UIs. Actually, I've witnessed my husband miss error messages on forms because they were in red, so they didn't stand out to him as he scrolled up and down the web page, trying to figure out why the form didn't successfully submit. Very frustrating for him indeed. Lastly, making sure that there is a high-level contrast between the color of text and its background color is super important. Whether you're looking at a desktop monitor, a laptop screen, or a smartphone, and whether it's a web page or an app or even a PowerPoint slide, not enough contrast between text and background makes it very difficult for many people with visual impairments to read. Let me continue with Angela's story. Through her research, she came across the Web Content Accessibility Guidelines document, affectionately known as the WCAG. The WCAG is a set of technical standards that explain how to make websites, apps, and other digital assets more accessible to people with disabilities. The Web Accessibility Initiative of the World Wide Web Consortium, the W3C, publishes the guidelines. These were developed in collaboration with people and organizations around the world. The WCAG guidelines are intended for web developers, web author tool developers, and web accessibility evaluation tool developers, as well as anyone who wants a standard for web accessibility. WCAG guidelines are not legally required, but they are globally adopted standards that strive to make the internet more inclusive for everyone, including those with diverse needs. The guidelines can also make web content more usable for everyone in general. The WCAG standards are categorized based on four main principles: perceivable, operable, understandable, and robust, often referred to as the POUR principles. Perceivable means that information must be presented in a way that users can perceive it using one of their senses. In other words, a user must be able to comprehend the information presented. It can't be blocked from all senses. For example, captions are provided for audio content, descriptions are provided for video content, and color is not the only way to convey information. Operable means that all users can effectively navigate your website. If your site requires users to interact in a way that's not possible for them, your website is not meeting this principle. Users must be able to interact with the components of the page, such as navigation features and the user interface. For example, people who can't use a mouse should be able to effectively navigate your website using just the keyboard or voice commands. Another example of operable would be the purpose of each hyperlink could be determined from the link text alone. The principle of understandable is just that. Users must be able to understand the information as well as understand how to operate within the user interface. For example, labels are provided when content required input from the user, and navigation mechanisms that are repeated on multiple pages appear in the same relevant order on each page. Lastly, content must be robust enough that it can be interpreted by a wide variety of possible user agents, including assistive technologies. The WCAG guidelines contain success criteria, which are testable statements that are organized under the four main POUR principles. The success criteria are categorized by three levels of conformance: level A, level AA, and level AAA. Some say that single A is a must-do, that double A is a should-do, and AAA is, quote, reaching for the stars. The goal of most website owners is AA conformance. This is also the level at which most legal requirements are judged. Level A is the bare minimum. It is typically considered unacceptable. Level AAA is the highest possible conformance, and for some content, it can't be achieved. Let's see how we can use the WCAG to evaluate a web page or UI screen for the two common accessibility issues that Angela uncovered. One accessibility issue was that color should not be the only way to convey information, such as with error messages. Another issue was that foreground text should have sufficient contrast with background colors. Let's tackle the using only color to convey information accessibility issue. Perusing through the WCAG Quick Reference Guide here online at the w3.org website, notice the 1.4.1 Use of Color, Level A. Color is not used as the only visual means of conveying information, indicating an action, prompting a response, or distinguishing a visual element. Notice that this is a Level A success criterion, so it's a must-do. Listed here are two different situations with suggested techniques to fulfill this success criterion. For example, in situation A, G14, Ensure that information conveyed by color differences is also available in text. In situation B, G111, it suggests using color and a pattern. I mentioned earlier that web form errors can be problematic if submission errors are only highlighted in red, something that I've seen too many times. If there was another visual indicator, such as an icon, or the error itself is outlined to stand out, that would be sufficient to meet this requirement. Here is another example that uses both color and a number, instead of just color, for choosing which triangle contains the right angle. Let's turn our attention to the color contrast accessibility issue and head back to the WCAG Quick Reference Guide online. We know from before that this is success criterion 1.4.3 minimum, whereas the visual presentation of text and images has a contrast ratio of at least 4.5 to 1, except for the following conditions: large text, incidental, and logo types. For situation A, under sufficient techniques, for G18, if text is less than 18 point if not bold and less than 14 point if bold, then contrast ratio must be at least 4.5 to 1 between text and background text. Compared to situation B, if text is at least 18 point if not bold and at least 14 point if bold, then the contrast ratio needs to be at least 3 to 1 between text and its background. In case you are wondering, 18 point means size 18 font and 14 point means size 14 font. Other techniques are listed here, and we could also include understanding technique links to get more information. You may have noticed that 1.4.6 is contrast enhanced. This is level AAA. The contrast ratio for this success criterion is 7 to 1, text to background color, for those people who still cannot read text with minimum contrast. So going back to criterion 1.4.3, minimum contrast, level AA, text and images of text is to have a contrast ratio of at least 4.5 to 1 with those three exceptions. But how can we determine this? We need a tool that can provide us with these contrast ratios given text and background colors. There are many contrast checker tools available online for free, and numerous ones listed under the Related Resources section for each of the success criterion. While it's not an endorsement, my friend Angela found this website, contrastchecker.online, to be very easy to use. As you can see here, it provides two color palettes to choose both the foreground text color and the background color, then immediately displays the contrast ratio. Below that, it shows whether it meets the 1.4.3 color minimum and the 1.4.6 enhanced success criterion. The default colors of white text on this purple background meet both AA and AAA level conformance for both large text and not so large text and images of text. Farther down on this page, there are links to the WCAG guidelines for more information. So, selecting different color combinations will produce the contrast ratio. It's interesting to see what's acceptable and what's not, and the hexadecimal values that it displays color combinations, and the hexadecimal values that it displays for the color combinations can be easily saved.
So there you have it. Like Angela, you now know how to use the WCAG guidelines to evaluate different aspects of a web page or UI screen for accessibility. Not only will more accessible websites and applications be helpful for people with disabilities, but they will also be more user-friendly for everyone. As a web programmer or application developer, not introducing these two fundamental accessibility issues into your software will go a long way in creating accessible software. Creating web pages, GUI screens, or even PowerPoint slides using just these two simple accessibility principles enable thousands, no, millions of people to more effectively and efficiently use these digital products. And just like that, you become a better programmer, a better designer, or a better web developer.